Friends, we are going to discuss today a very important topic of rotary equipment called shaft alignment. You must be eager to know what is shaft alignment. A shaft alignment is a process of aligning two or more shafts with each other within a tolerated margin. It is an absolute requirement for machinery before the machinery is put in service. What are the most common causes of machine vibration? Imbalance, misalignment and shaft runout, centering, wear and tear, looseness. These are the most common causes of machine vibration. What is imbalance? Imbalance is a heavy spot of rotary component. It may come in the rotary equipment due to machining error, casting flaws, or maybe due to maintenance issues like deformed or dirty fan blades, missing balance weight, etc. And when these defects come on a rotor assembly, there will be a centrifugal force, and that force is equal to m omega square r, where m is equal to mass, r is radius of unbalanced mass center, and omega is angular velocity. If mass increased, then centrifugal force will increase. If r means radius of unbalanced mass center increase, then also centrifugal force will increase. And if the vibration increase with the RPM, that means angular velocity, then we can say with confirmation that it is due to imbalance. Misalignment also create machine vibration. We'll discuss in detail now. Centering, it is the rotor center line and casing center line must be the same. If this center line is not same, then the flow will not be streamlined. Then flow induced vibration will come. So centering should be perfect. Then wear and tear is also, if a machine is running continuously for prolonged time, then due to natural wear and tear, clearances will increase, and that will increase the load, and as a result bearing vibration will appear. Looseness is also similar to that. If looseness is there, then certainly unbalance will come and vibration will appear. Effect of vibration. Due to vibration, there will be rate of wear and tear, and that means reduce the bearing life. There will be noise, cause safety problems. It will take excessive power, may damage product quality, and the vibration may be so severe that we have to take out the machine from line. That means the production of the plant will suffer. Characteristic of vibration. We see the vibration can be of two types: radial vibration and axial vibration. Imbalance create radial vibration, misalignment create axial vibration. Parameter of vibration. There are three factors in vibration. It's called, one is amplitude, then second one is called speed, and third one is called frequency. Amplitude means the vibration, how much distance it is taking place, the peak to peak. And speed means how much time it is take to reach the peak. And acceleration means how many times it touches the peak. So these are the three parameters with which we are measuring the vibration. Misalignment can be of two types. One is angular misalignment, another one is called offset or radial misalignment. Misalignment always generate heat, that means it is wastage of energy. If you see the angular misalignment, the x-axis denote the misalignment, y-axis denote the percentage increase of power consumption. The unit of x-axis is inch thou per inch. Suppose we are doing alignment and allow misalignment 0.075 millimeter for a coupling dia of 6 inch. That means its value will be 0.5 thou per inch. And if you see 0.5 thou per inch, the energy power consumption will be negligible. Similarly, if we allow radial misalignment up to 10 thou, that is 0.25, then also if you see the power consumption will be around 0.5% or less than 0.5%. That means power consumption wise misalignment is not so significant, but misalignment should not be allowed. If you allow this misalignment, then there will be wear and tear of the bearing, there will be wear and tear of the mechanical seals, bearing seals, coupling may get damage, and there will be unscheduled downtime. You can reduce this unscheduled downtime if you do alignment properly. Before doing any alignment, we have to do the sole plate leveling. What is sole plate? If you see the drawing, there are so many sole plates we are using on the foundation block, concrete block, and this sole plate to be grouted with the foundation block. The sole plate located longitudinally as well as crosswise, transversely. This sole plate need to be leveled. First, we have to select one sole plate with reference to construction drawing to finalize the elevation of the equipment. Once you finalize the elevation, then we have to go for leveling of that particular sole plate with the help of a master level gauge whose least count is 0.02 millimeter per meter. Whether the least counts or accuracy of the level gauge is perfect or not, we have to ensure it. How we are doing it? Suppose we are recording a reading of level by master gauge, then reverse the master gauge 180 degree, take the reading several times, and you will get, if you repeatedly get the same reading, that means your level gauge is perfect. Then other level gauge to be installed, to be checked with respect to the reference plate, and the elevation should be to a tolerance value of plus minus 0.6, and the leveling of each and every sole plate should be within 0.04 millimeter per meter. These are the sole plates over which, and once the sole plate leveling is over, we have to grout it, and after drying we can place the machine structure, machine base plate over the sole plate. Then the base plate leveling procedure. This is called the base plate over which the mounting plates are there. While doing the base plate leveling, we have to determine the high end of the base plate, because if you choose a low end of base plate, then suppose you need to take out some seams to level the base plate, then you cannot do that. But if you choose high end of the base plate, then you can add seams or you can remove seams also. In the similar way, like sole plate, we have to level the base plate crosswise as well as longitudinal wise. We have to tight each and every foundation bolt and see the level gauge. If level is perfect, then there is no change in the level, then we can say the base plate leveling is over. These are some pictures where we have shown the diagram how to do the leveling. This is a driven machine. You see, we are checking the level with the master level gauge crosswise. You see, here we are checking the level of the drive machine with reference to the longitudinally, that means the same center line with the driven machine. Here we are checking the level of driven machine, means pump. Here in the case particularly it is pump crosswise as well as axial wise. We can take the help of a straight edge to easy the level check. What is the effect of leveling? Suppose your level is not perfect, it is inclined. So we know the casing is fixed with the foundation bolt, but rotor is free. So rotor tendency will be due to gravity to come to the lower elevation side, and this will give some axial thrust on bearing, or vertical force will take care of the bearing. So though the value of this axial force will be very negligible, because we cannot allow axial misalignment, axial level more than 1 degree or 2 degree. That means this value will be very less, but still we have to do the leveling. After completing the level check, next step is to check the soft footing. Soft footing to be checked with piping disconnected from the equipment body. Soft footing to be checked in each foot and not on coupling. Maximum permissible movement at each foot is 0.05. A soft footing may come due to twisted, bent and wrapped frame or base plate. It may be due to number of seams under a foot. If dirt is there, gap is there, oil is there, then also soft footing may come. Soft footing to be checked each and every foot of drive and driven shaft. First, we have to tight each and every drive shaft, then put the dial gauge on each foot, and then loose the foundation bolt and see the dial gauge reading, and again tight the foundation bolt and see the dial gauge reading. If dial gauge reading do not change and remain within 0.05 millimeter, that means soft footing of that particular foot is correct. Then move to next foot. There also we have to repeat the same activity. Loose the foundation bolt, tie that foundation bolt and see the dial gauge reading. If the dial gauge reading do not change or remain within 0.05 millimeter, your soft foot reading for a particular foot is okay. Like this, we have to repeat the same activity to all the foods of drive and driven machine. Shop footing can be of several types. One is parallel shop footing. That means the gap between the foundation plate and the foot is same. If you tight the foundation bolt, then what will happen? This particular portion of the leg will be under stressed condition, and if you allow the driven machine to start, this leg can crack anytime. So you have to fill this gap, tie the foundation bolt, loose the foundation bolt, and see is there any change. The dial gauge reading. If dial gauge reading is not change, do not change, or even within not 5 millimeter, that means there is no shop footing. It can be of angular type. This foot is angular. The outside projection is there. This is inside projection is there. Once you tie this foundation bolt, this particular edge will touch the base frame, touch the base, and there will gap will remain there, and here the gap will remain there. So this particular portion of the leg will be under stress condition. To remove this shop footing, we cannot do in position because tapered seam is not available. So we have to take the base frame out, do machining here, make it parallel, and remove the shop footing. Quasi shop footing means there are so many seams we are using between the palm foot and the base frame. So if there is air gap or bent seams or there is oil, then there will be some spongy action. So number of seams to be reduced. That's why we have to use higher thickness seams, such things, and remove this quasi shop footing. This type of shop footing, it is called stress-induced shop footing. That is very difficult to detect because when you are doing the shop footing check, we disconnect the piping from the machine and decouple the driven machine with drive machine. And when shop footing is over and when you are couple it or connect it, then if there is misalignment or there is tension or there is strain in the pipeline, then this particular leg will be in stress condition, and if you keep this allow this machine to run, then it can break from wire. There is another way. If you compensate the alignment reading with the shop footing reading, then you may get good alignment reading, but your stress will always be there. So we cannot allow the compensation of shop footing reading with alignment reading. That will not give the correct result. Misalignment can be of three types. Radial misalignment, it can be vertical, it can be horizontal. Axial misalignment, it can be vertical, it can be horizontal, and combination of radial and axial misalignment. In the picture, it is clearly shown that this is the radial offset, this is the angular offset between the two coupling halves, and this is the combination of two radial offset as well as the axial offset. If misalignment is there, then what will happen? Suppose if misalignment is there, that means this is the force perpendicular to the base frame of the shaft. So there will be if there is an angle, then this angular misalignment is there. Then we can divide it into two components. One is axial direction, another will go to vertical direction. Axial direction will give thrust load and radial direction will transmit the torque. But if you see the force F is not full F is transmitting to torque, its sine component will transmitting to torque. That means full load is not transmitting. That's why misalignment is not advisable. We have to correct the misalignment. Normally we are doing alignment during morning time. If you correct the morning alignment or leveling in morning and check it in afternoon, you will see, you will notice that the level got disturbed, alignment got disturbed. Because if you see the afternoon, or during lunch time, noon time, the heat of the sun will this particular portion, one half of this portion, and it will expand more, and this side will comparatively cool, so this will expand less. So the alignment and leveling will get disturbed. So it is advisable to do leveling or do alignment, particularly the temperature the pump is going to run, or early in the morning, so that there should not be any effect of sun. Types of alignment: we can do the alignment by rim and face method, reverse rim or reverse dial alignment method, or laser alignment system method. Reverse or rim and face method, we have to use 3 dial gauge, 1 radial, 2 axial. Why you are using 1 radial and 2 axial? Because due to avoid the axial movement of the shaft. If you use 1 axial, then you will not get the correct axial reading, and we have to rotate both drive shaft and driven shaft simultaneously together. What is the advantage of rim and face alignment method? Because this method is more accurate, and the millwrights or technician can visualize the misalignment, visualize the position of the shaft, seeing the reading of misalignment, angular misalignment and offset misalignment, and do correction correctly. But disadvantage is we have to install 3 dial gauge, so all the dial gauge will be very close to each other. Your tools can touch the dial gauge and reading may get disturbed. You have to correct the sag, and if your coupling dia is bigger than the space, than the coupling space, then this alignment will give better result. But if your coupling dia is less than the spacer, then this alignment reading will not give proper reading. It will not be so sensitive there. In this particular case, when coupling dia is less than the spacer, then reverse periphery or reverse dial method will give you the better result due to sensitivity of the reading. How to do the alignment? Before start the alignment, we have to adjust the DBAC. What is DBAC? Now, distance between shaft end. For flexible coupling, it should be kept within plus minus 0.25 mm. For gear coupling, we have to keep the distance tolerance plus minus 0.75 mm. DBAC to be set keeping the magnetic center, keeping the rotor of motor particularly in magnetic center. If you pull the motor shaft and couple it, and when it was not in magnetic center, when you start the motor shaft try to come in this magnetic center, and it will give axial load. So you have to mark the magnetic center and DBAC, set the DBAC. And before doing any alignment, we have to all the foundation bolt to be perfectly tight. One dial gauge you have to put in radially, and 2 dial gauge axially, and level to be adjusted. The level should be perfect, both horizontal as well as vertical direction. This is the dial gauge. If you see, the dial gauge have a plunger. If you move the plunger upwards, then this pointer will move clockwise. If you pull the plunger downwards, the pointer will move anti-clockwise. Similarly, there is a small scale. If you push the plunger, it will move to clockwise direction. If you pull the plunger, it will move in the anti-clockwise direction. And the one division of this dial gauge denotes 0.01 mm, and once the pointer rotate 360 degree, then the plunger will move 1 mm and 1 millimeter. We have to keep this dial gauge perfectly try to keep the dial gauge perfectly at the middle, so that you will get both positive direction reading as well as negative direction reading. Before start alignment, we have to keep the dial gauge vertical position lift the plunger 2-3 times, then drop it and see the plunger coming back to its original position. Rotate the rim, put the plunger in 0 position, again repeat the same thing and see the plunger and pointer is coming to 0 position. That means your dial gauge is accurate. Then mark the coupling hub 90 degree, 180 degree, 270 degree. First, we have to take a set of reading and 2-3 times we have to take the readings and establish the same reading is coming, and we have to check whether the reading is valid or not. If reading will be valid if A plus B is equal to C. Suppose you are taking this reading, then one side is plus 10, other side is plus 14, then bottom should be plus 24. It may vary 1 and 2 division, that is due to the point where we are going to take may not be that perfectly 180 degree, 90 degree or 270 degree, or maybe the parallel side effects. But in normal case, A plus B should be C. For doing horizontal, radial and axial alignment, each and every equipment has been provided with jacking screw. With this help of the jacking screw, we can pull the movable machine and angular shift the movable machine. Angular movement is also possible. We have to do the horizontal, radial and axial adjustment, alignment first. For that, we have to keep the dial gauge horizontally at 90 degree position, set the dial gauge both axial, 2 dial gauge axial, 1 dial gauge radial in 0 position, rotate the shaft, drive shaft simultaneously to 180 degree and 270 degree position and check the reading. And according to the direction of the reading, you will get the total indicator reading. Then you have to adjust the horizontal, radial offset by pushing or pulling the movable machine half of the total indicator reading. Similarly, angular set also we have to angular movement. We have to do the correct the angular movement by giving the total angular half of the total angular misalignment. Once you adjust or shift the driven or shift the movable machine, you have to release the jack bolt. Your reading should not get disturbed. If reading get disturbed, that means your foundation bolt may touch with the whole of the motor base frame or driven machine. Then if you try to compensate that reading with alignment reading, you may get perfect alignment reading, but your alignment procedure will not be correct, and your aim will not be satisfied. When you start the pump, it will vibrate. So we have to remove that strain either by increasing the hole dia or take skin cut on foundation bolt, so that once you release the jack screw, ring should not change, and you have to just simply after adjustment release it and simply touch it, simply touch it. Never try to do vertical misalignment, radial as well as axial first, because if you do vertical and try to adjust vertical misalignment, radial and axial, and then correct the horizontal, your alignment will not come in one time, because your vertical alignment will get disturbed. Vertical alignment will get disturbed. So you have to do horizontal, axial and offset first, and then you take the reading of vertical misalignment reading with radial and axial. One horizontal horizontal alignment is over, So how do you come to know? When you put the dial gauge in 90-degree position and rotate it to 180-degree, 270-degree position, then your dial gauge reading should be 0, 0. Then you put the dial gauge on vertical position, set it 0, 0 for all the 3 dial gauges and take the reading, and then you have to do the little paperwork for do the correction. Suppose after doing the horizontal misalignment correct, you will get radial reading, vertical radial reading. You will get radial reading like this and axial reading like this. There will be 2 dial gauges. One is A1, another one A2. For A1 you have to take as reference. Then the combined axial alignment reading will be this minus this by 2 equal to 0. This minus this by 2 is equal to minus 0.4. Minus 0 plus minus 0.4 divided by 2 is minus 0.4. This minus this by 2 minus 0.4, and this minus this by 2 equal to minus 0.84. So these 2 reading, this will be radial reading, this will be combined axial reading. If you see the radial reading, you will see the movable equipment is down by 20 division diametrically, and radially it is 0.1, and similarly axially it is 0.084. Angular misalignment is there. Angular misalignment can be of 2 types. It can be closed at the bottom, it can be open at the bottom. To do the alignment, axial misalignment correct, for particularly when the bottom is closed, we can remove this much of seam from the front foot, or we can add this much of seam from the rear foot. Both the decision you can take, but once you remove this much of calculate and remove this much or add this much of seam, then what will happen? Your radial reading will going to change, and you have to adjust the radial reading accordingly and to do the final alignment. Similarly, for when bottom is open, so you can push, insert some seam at the front foot, or remove some seam from the rear foot. In either the cases, the total requirement of seam for doing axial and radial alignment will be remain same. We will discuss this thing in next slide and with calculation. Suppose coupling die is 200 mm. Distance of the 2 foot is 1000 mm. Coupling center to first distance is 200 mm. In the first case, we have decided to remove the seam from the back foot. Suppose we have to remove the X foot. How we will calculate how we will come to know the value of X? That means X divided, it is a simple trigonometry, simple geometry. X divided by 1000 is equal to 0.8 divided by the 200. So we are getting X is equal to 0.4. That means we have to remove 0.4 seam from the rear foot. This will act as a fulcrum. Once you remove 0.04 seam from the bottom, this particular point will move up because this is act as a fulcrum. So how much center will move, that also we have to find out. So again the same calculation, X divided by 1000 is equal to this distance is 200 divided by this distance, that is X. So how much we are getting X? We are getting X is equal to 0.08. So X means center will move. That means the diametrical reading will be how much? Diametrical reading will be 0.16. 0.08 into 2.16. We have seen in the initial reading that this coupling, the center or diametrical reading is 0.2 down, and now we are seeing that coupling is now 0.15. After doing this axial correction, coupling is moving up to 1.6. That means how much still it is 0.04 down. To do this 0.04 correction, we have to add 0.02 in the front side and we have to add 0.02 at the rear side. But rear side we have already removed 0.4. That means 0.38 we have to remove from the rear side. 0.02 we have to add in the front side. Then the vertical, radial as well as the axial alignment will be correct. 100% 0-0. In the next case, you can add seam at the front foot also. but reading will remain same. Just I will give you the calculation, but reading will remain same. Final reading will remain same. If you add x at the font, you do the same calculation. X divided by 1000 is equal to 0.08 divided by 200. That will give you 0.4. So when this will come 0.4, this will come 0.4. That means this center we take this as a fulcrum, and this 0.4 we are adding. That means how much this will move up. This will move up. How much? Now x divided by 1000 is equal to x means 0.4 divided by 1000 is equal to x divided by 1200. Similar triangle. So this value is coming 0.48. This radius, the center will move to 0.48. Then diametrically, what will be the reading? That will be 0.96. But your rotor was initial reading was 0.2 downwards. So how much radial offset will be there? Now 0.96 minus 0.2, that is 0.76. 0.76 up. That means you have to remove how much? This divided by 2. That means this divided by 2 is how much? 0.38. So we have to remove 38 from the bottom side and 38 from the front side. But we have removed, we have add 0.4. So how much we have to remove, the balance removed? Only 0.02. So you see the reading. If you add font or if you remove from the rear foot side, your total reading will even say only calculation will be different. So with this we can complete the face and rim method to do the alignment correction, radial as well as angular. There is another one alignment method which is very popular near millwrights or technician. It is called reverse rim alignment method. In this method, we are measuring the reading only on coupling rim, that means radial readings, and very close to vertical and horizontal axis. The advantage and disadvantage of this reverse rim dial alignment method is it is most popular method. Millwrights are very familiar with this type of alignment method, and when the spacer length is 400 millimeter and coupling half dia is 100 millimeter, then this method will be more sensitive because we will get 4 times more sensitive reading than rim and face method. Here, removal of coupling spacer, we can eliminate the, for taking the reading, we can eliminate the removal of coupling spacer. Sag, no doubt, we have to measure, and axial float, there is no need of putting 2 dial gauge axially. The axial float, there should not be any problem for this type of alignment method. This method disadvantage is it must be turned unless it is 2 shafts to be turned simultaneously. Indicator sag you have to taking care of. We have to purchase the commercial brackets, and where the DBAC diameter is greater than the DBAC, then this method will not be so sensitive. The rim and face method will be more sensitive and more accurate. In this process, it is a graphical method. In this process, the plus and minus sign should be included on the graph to tell the direction. For fixed component, the reading will be, plus will be in this side, minus will be on this side, and for wheel machine, minus will be on this side and plus will be on this side, and it is valid for both horizontal and vertical readings. If you see the diagram, we have to measure the distance between the coupling hub, then distance of movable machine first foot of the movable machine from the coupling hub and the rear foot from the coupling hub, or distance between the two foot. Here you have to take the reading vertically, and here we are taking the reading horizontally. To do this alignment, first of all, we have to take a graph and we have to record the distance from the distance between the coupling, distance of first foot, and distance of the two foots, and then we have to plot the reading. In first, the reading on the fixed that is called fixed machine, that is -50. Then it will be on this side. We have to take the half reading, and plus reading will be there on the movable machine, and half of this reading to be plotted on this side. Join these 2 points, projected it, and see where it is projected it towards the motor side, towards the movable sides, and then measure the distance of the fixed center line and these 2 points, rear foot and front foot, and you have to push the movable machine to this direction, this mass distance, then this center line of this movable machine will be coincide with the fixed center line of the machine. That means horizontal misalignment is completed. Similarly, for vertical alignment, we have to follow the same sign. It is plus on the fixed side, that means it will be on the upward side, minus on the movable side, so it will be on the upward side. We have to take the half of this reading. We have to plot the half of this reading, 18 reading minus 0.9, and then connect these 2 points, project it and see where it is cutting this rear foot and where it is cutting the front foot. Then take this measurement. You will get direct measure through the as per scale on the graph paper, and then you have to remove this much seam from the rear foot, this much seam from the front foot, and then your vertical alignment will be over. Then this will be perfect center with the fixed machine. So horizontal and vertical, this alignment process is very easy and very easily acceptable to all the millwrights and technicians. If you see where to use reverse rim and where to use rim and face method, if you see this picture, it will be clear to you. Suppose your coupling dia is 100 mm, distance between shaft end is 400 mm. Then for axial misalignment of 0.04, we are getting a radial movement of simple method, triangle method, radial movement of 0.16. That means reverse periphery method, this will be more suitable because to more sensitive, and because to get axial misalignment 0.04, we are getting a reading of 0.16. So it is more sensitive for reverse periphery method or reverse dial method. Suppose your coupling dia is 200 mm, spacer length, distance between the coupling is 100 mm. So if you for axial misalignment of 0.08, you are getting only half of the reading, that means 0.04. That means in this type of coupling, like rim and face method will be more sensitive, more accurate than reverse periphery method or reverse dial method. So we come to the conclusion that reverse rim or reverse dial method will apply the reverse rim or reverse dial method when coupling dia is less than DBAC, and rim and face alignment method when coupling dia is greater than DBAC. Then we'll see another third method, which is also now becoming very popular nowadays. It is called laser alignment method. In this method, laser beam we are using to do the alignment. Here, there will be one will be laser will be mounted on one or both shaft, and receiver or reflector will be mounted on other shaft. We have to rotate both the shaft simultaneously, and the reading will be recorded on the computer supplied along with the laser alignment kit, and that will give you the direct result of misalignment, horizontal as well as vertical. The advantage of this type is we have to measure the distance between the front foot and your rear foot, coupling dia, coupling DBAC, and you have to fit it on the computer, so the human error you can eliminate. And potential accuracy laser is much more accurate than the dial gauge, so you will get the accurate reading. Here you need not do any calculation for horizontal and vertical. This will give you direct one element reading, will give you direct how much horizontally you have to move, how much vertically you have to move. You need not require to decouple it to do this alignment method. And universal brackets are also available. Only you need the millwright to be trained to use this type of alignment kit. Disadvantage is this kit is very costly, and millwright or technician does not feel the doing of actual alignment because they did not do any calculation. And if any vibration is there on the pipelines and others, this will not give you the correct reading. So this is the only disadvantage. Otherwise, the laser alignment is more accurate and you need not do any calculation. Human error can be eliminated if we use laser alignment, and it is become familiar day by day. Bolt and bolt clearances and holding down bolts. There should not be any undercut. I have told you, if it is touched with the base frame hole, then there may be a tension. But you have to choose a holding bolt so that there must be some clearances and it should be free. And we should not use any lock washer for holding down bolts. If coupling dia is very small, then we can use alignment disc so that you can get a better distance between the two axial reading, and this will give you the better reading, and elimination or fouling of two dial gauges due to small coupling dia can be eliminated in this process. The reverse rim and laser method, the maximum tolerance given is 0.5 mil per inch. Suppose that means if your coupling dia is 150, then we have to take coupling dia is 150 and the reading is taken within the two pointer is 150, then total indicator reading will be 0.5 inch divided by inch per mil per inch or 0.5 millimeter per meter, then it will be divided by 1000, it will give you millimeter, then you have to multiply it by the coupling dia divided by the 2 because TIR total indicator divided by the 2 and divided by the coupling dia. That will give you the total missile tolerance. This will give, that is equal to 0.025 millimeter. Similarly, rim and face method, the maximum angular misalignment should not be greater than 0.03 degree. Suppose normally we tell that axial misalignment this much value, some value we are mentioning, some 0.3, 0.75, 0.8, 0.1 millimeter, but that does not mean any axial misalignment. You have to divide it with the diameter of the coupling, and then this will give you the angle, and then only it is having the meaning. Otherwise, only simple axial reading does for rim and face method does not have any value unless you give the diameter, and you have to measure the angle, and maximum angle permitted is 0.03 degree. Similarly, for offset total TIR shall be with total indicator reading shall be 0.04, radial diametrically actually it will be 0.02. In the previous slide, I have told you about sag, and you have to consider sag in the alignment reading. What is sag and how to measure it? sag is bound to be there in a bracket. We have to mount the bracket along with the dial gauge on a horizontal pipeline or in lathe or on shaft, and then rotate the shaft 180 degree, and whatever reading we are going to get when the bracket will come downwards, this is called the sag reading. It should be always minus, and this reading should be incorporated in the alignment reading. The maximum permissible sag for each bracket should be less than 0.8 millimeter per meter of span or less than 0.8 mils per inch of span. Suppose your sag reading is coming like this: 0, minus 0.4, minus 0.4, minus 0.8. Then final alignment reading of this reading will be considered as 0.0 reading. 0.0 reading. Similarly, if the coupling dia and DBAC are same, then minus 0.8 axial reading should be considered as geoaxial misalignment. If your coupling dia is double than the DBAC, then minus 0.8 into 2, that is 0.16, will be considered as 0.0 reading for angular misalignment reading. Suppose the equipment is handling hot fluid, then the casing is supposed to expand, and we have to, as well as the shaft will also expand. So we have to provide, while doing the alignment, the cold alignment margin we have to provide. How to calculate how much expansion will take place? Normally the foot mounted pump is going to expand. The formula is L2 minus L1, the expansion is equal to L1 alpha delta T. Suppose it is handling 80 degree centigrade fluid, and your length is from base frame, pump center line, from shaft center line, from the base frame is 400 millimeter, then your expansion will be L2 minus L1 is equal to 412.1 into 80 minus 36 into 10 to the power minus 6. What is alpha? Is thermal coefficient of expansion at atmospheric temperature. Its value is 11.9 micron per meter per degree Kelvin. At 80 degrees centigrade, the value of alpha will be 12.01 millimeter at 80 degrees centigrade per millimeter per degree centigrade into 10 to the power minus 6. So this value will be, expansion will be 0.16. So this much margin we have to left while doing the cold alignment. When the pump will be running and handling this hot fluid, then both the pump center line and motor center line, or whatever may be, will be on the same center line. Fixed component, I have told you earlier slide, the gear, if equipment train having gear, then gear you have to take as a fixed component. If it is not, gear is not there, it is simple drive and driven machine, then the machine which is having rigid process nozzle shall be considered as fixed element, and normally motor shall be considered as movable element. See, I have told you, if we use maximum number of seams, then this will give a soft, quasi soft footing experience. You will experience a quasi soft footing. Then to avoid this soft footing, we have to limit the maximum number of seams used per foot is limited to 5 numbers, and the stack thickness should not be more than 12 millimeter. And if it is 12 millimeter, then minimum one number of 3 meter seam should be available, and there should not be any seam less than 0.5 millimeter. Taper seam, laminated seam, brass seam, aluminium seam, cast iron seam is not permitted. Seam, only SS seam with surface finish 64 RA or better, can be used, and seam, when you are going to use, it should be full bedded of the foot, palm foot. Normally, when we do alignment, we calculate, we put seam at far end and the near end of the coupling. In between foundation bolt, we have to fill the gap, fill the gaps, and that how much gap is there. If it is for a long base frame, the gap will be different for different foundation bolt. So we have to calculate simple geometry. With simple geometry, this gap is there, this gap is there, then we can find out how much gap is there in between the foundation bolt, and you have to fill the gap with the required seam to avoid the vibration of the foundation frame, base frame. Dowel pin. How many dowel pins we should use? Normally for heavier machine, more than 2 dowel pins are used. Dowel pins are used, and minimum number of dowel pins should be 2, and that should be diametrically opposite. If 1 millimeter thickness, the plate thickness is 1 millimeter, then dowel pin thickness should be between 1 inch. If the plate thickness is 1 inch, then dowel pin thickness should be 1/4 to 3/8 inch. If plate thickness is 3/4 inch, then dowel pin diameter should be 316 and 932. 1/4 into 3/4 equal to 316, and 3/8 into 3/4, that is 932 or 1032 inch. So this should be the diameter of the dowel pin. Piping alignment, I have told you, if piping having stress, then then this will create a soft footing, and if you compensate this pipe stress with alignment reading, your purpose will not solve. Your pump will vibrate when it will be running. So the stress should be eliminated. So the bolt we are going to use to connect the pump nozzle, suction discharge nozzle with suction discharge flange, the diameter of bolt should have an offset maximum 0.15 millimeter offset, and the taper or misalignment of the nozzle with the flange should be should be less than 0.1 millimeter per centimeter of pipe flange, and it should be maximum 0.75 millimeter. If flange dia is up to 10 inch, then it should be 0.5 millimeter. This gap should be measured with a feeler gauge, and if it is more than 0.01 per millimeter per centimeter, then we have to cut the flange and re-weld it and make it parallel. And the flange gap should be plus minus 1.5 millimeter, depending on the thickness of the flange, thickness of the gaskets. Pipe drain for strain, when you are connecting the suction discharge plane with the suction discharge nozzle, then we have to tight the suction discharge nozzle with the flange 10%, 30%, gradually 10%, 30%, 100% with the required torque, and there should be 2 dial gauge mounted radially, one horizontal, one vertical, and we have to see the reading. Yes, the reading should be within 0.5. If it is go beyond 0.5, then we have to cut the pipeline and rectify it. Spring support also to be checked, cold reading of the should be checked, and it to be adjusted as per the OEM guidelines. Pump suction line should be, there should be a straight line of 5 times diameter of the suction lines of the pump. In between this 5 times diameter length, there should not be any strainer, any valve, any reducer or T, and to avoid the turbulence of fluid entering the pump suction. Pump suction pipe shall be designed with no high point to collect the vapor. If fluid handle is high temp is supposed to vaporize at the working temperature, at the operating temperature, then a slope, minimum slope 10 millimeter per meter towards the pump side to be provided to prevent accumulation of vapor. Then normally we are using a reducer to pump suction line. Normally pump suction line is bigger than the nozzle size, and so we have to use a reducer, and when we are using reducer in pump suction line, it should be eccentric reducer and its straight portion should be on the top. Similarly, we are using higher size pipe diameter in the discharge side, and there the reducer we have to use, that is concentric reducer. If in the pump suction line, due to geometry or due to constraint, you have to use some tapping or strainer within the 5D diameter, then a straightener to be used to avoid turbulence. And the first elbow used in pump suction line should be a long radius elbow. Friends, I think I have covered all the points of alignment, how to do alignment, what are the thumb rule available for alignment, but still I tell you, you should follow the OEM guidelines. If OEM guidelines is not available, then whatever thumb rule we have discussed, you can follow that one, you will get good result. Thank you very much for patience listening.